Okay, hello everyone. So last time we talked about how we can graph rational functions using key features, which are asymptotes and the intercepts. And then as we saw, this was not easy to do, okay, because there were a lot of things to keep track of, all these asymptotes and intercepts. But as I mentioned, the goal is not for us to master this 100%, but rather you want to treat this as kind of a preview of what's to come next year. A lot of these ideas will show up again in your next math class if you're taking pre-calculus. So I want to make sure that you guys are familiar with some of these ideas so that they won't be completely brand new to you guys next year. Okay, so let's first do a quick review of everything we saw last time, and then we'll just do a few more graphs just to get the hang of this. So if we're given a rational function, which again is a ratio of polynomials of the numerator over denominator. So for vertical asymptote, we're first going to set the denominator equal to 0 and then solve for x. And then for x-intercept, it's the opposite. We set the numerator equal to 0 and then solve for x. And then for y-intercept, that's actually the same for all types of functions, not just rational functions. You would substitute x equals 0 and then solve for the y value. And then lastly, the horizontal asymptote, that's kind of the trickiest one. We're going to compare the degrees. So if the degree of the numerator is bigger than the denominator, then there's no horizontal asymptote. If it's vice versa, if the bottom is bigger, then it's y equals 0. And then if the degrees are the same, then you look at the leading coefficients and then you divide them. Okay, once again, we'll do more examples of that just to see how they work. Okay, so we'll first start with a kind of a warm-up. So this is something that's similar to what we saw last time. And again, whenever we're graphing these, the first things we should do is to always find the key features. Okay, so I'll start with the x-intercept. And again, that's going to be the numerator, set that equal to 0. And we saw why we do that during last time. So the numerator is 2x minus 4, make it equal to 0. And then solve for x. Add 4 to both sides, divided by 2, we get 2, comma 0. Make sure you write that as a point. And then for y-intercept, we set x equal to 0. And we get y is equal to 2 times 0 minus 4 over 0 minus 3. So that's going to be negative 4 over negative 3, which you can plug into a calculator. That's going to be something like 1.3, which is right about there. And there's my y-intercept. Okay, and then let's go to the asymptotes. I'll start with the vertical asymptote. And that's going to be setting the denominator equal to 0. And then solve for x. So x minus 3 equals 0. Solve for x, I get x equals 3. There's my vertical asymptote. And then let's graph that. And let me just kind of give you a quick explanation of why we set the denominator equal to 0 for the vertical asymptote. Okay, so we got x equals 3. So let's see what would happen if we were to plug x equals 3 back into our function. Okay, so I'm going to plug that in for x. So then I get 2 times 3 minus 4, which is 2. And then if I plug in x equals 3 on the bottom, I get 0. So then what's my y value? Well, y is 2 over 0, or 2 divided by 0. But as we all know, we're not allowed to divide by 0. It's undefined. Okay, so that's why when x is 3, we get a y value of undefined. So then that means x cannot equal 3. Okay, which is why we have a vertical asymptote there when x is 3. So whenever our denominator is 0, we get something divided by 0, which we all know is not defined. So that's why we have a vertical asymptote there. Okay, and then let's move on to our last key feature, which is horizontal asymptote. And then we will look at the degrees. So the degree on top is 1. The degree on the bottom is also 1. What happens if they're the same? Then we compare the leading coefficients. So same degree, look at leading coefficient. The coefficient on top is 2. On the bottom, it's 1. So it'll be y equals 2 over 1, which is just 2. So let's go ahead and graph that in as well, y equals 2. And then once you graph all these key features, the rest of the graph should be much easier to graph, right? Because we have these points here, so we know our graph is gonna go towards the asymptote. So then our graph will look something like this on this side. But that's all we have for now. We don't really have any graph or any points that are in this region that I just highlighted. We don't know if the graph is gonna be on top like this or on the bottom like this. That we do not know yet. Okay, so in that case, what can we do? Well, what you can always do with any graph, not just with rational functions, is you can just pick an x value, randomly, and then see what the y value is. Okay, so in this case, I'm gonna pick an x value that's in this region, and then I'm gonna see where the y value is. So let's say I'm gonna pick x equals 4. Oops. I can pick 4 or I can pick 5, 6, as long as it's in the region that's to the right of my vertical asymptote. So if x is 4, what's y? Let's plug into the equation. So 2x minus 4 over x minus 3. 2x minus 4 over x minus 3. Again, I'm plugging in 4 for x. And what do I get? I get 4 over 1, which is 4. So when x is 4, y is also 4. So that gives us a new point on the graph, 4, 4. 1, 2, 3, 4, and right over there. So what that tells us is that my graph is gonna be in this top quadrant right over here and not down here. Okay, now I just chose 1 point, but that's actually enough. But if you wanna be more precise and be more sure, we can pick a different point. We can pick, let's say x is 5. And then what I get, again, let's plug that in, 2x minus 4 over x minus 3. In this case, my x is 5. I get 10 minus 4 is 6. 5 minus 3 is 2. And I get 3. So I get x is 5, y is 3. And let's go ahead and plug that or plot that point, 5, 3. So my point should be right over there. So again, my graph is not perfect, but it's good enough, right? It's just a quick sketch. So my graph should go through that point and then go down like that. Okay, so that's the point of picking these points, is if we're not sure where my graph is going to end up, then we can pick a point to help us determine that. And then lastly, the domain and range. So domain is all real numbers except x cannot equal 3. That's where my asymptote is. Range, all real numbers except y cannot equal 2. That's where my asymptote is as well. Okay, so that's pretty much what we did last time. And then today will be much of the same, except one part's going to be a bit more complicated, is we're going to have multiple vertical asymptotes. Okay, but even though it's more complicated, the idea is the same. So we're always going to start by finding the key features. So I'll start with x-intercept, and then how does that go again? Well, that's going to be set the numerator equal to 0 and then solve for x. Now in this case, we notice that the numerator has no x, right? So if I were to set that equal to 0, negative 3 equals 0, then that's obviously not true, right? So this is not true because there's no x. There's not even x I can solve for. So that tells us there's actually no x-intercept, none, right? Again, the reason is because I don't see the x in the numerator. There's nothing to solve for. Okay, so there's no x-intercept. Y-intercept, how does that go again? Well, we make the x equal to 0 as always, and then let's solve for y. So y is equal to negative 3 over, plugging 0 for x, 0 squared plus 2 times 0 minus 3. I get negative 3 on top, I get negative 3 on the bottom, so I get 1. So what? Y-intercept is 0, 1. And then moving on to the asymptotes, let's start with the vertical asymptote. That's going to be, go back up here to your notes, set the denominator equal to 0. Okay, so let's do that. X squared plus 2x minus 3 equal to 0. And by this point in the year, hopefully we all know how to solve a quadratic. Is you want to try to factor. And in this case, this can be factored. Two numbers that add up to 2 multiply to negative 3 plus 3 minus 1. So I get x equals negative 3, x equals 1. So there it is. We have two different vertical asymptotes, negative 3 and 1. So let me write down both. Okay, and then Finally, horizontal asymptote. Let's go ahead and look at the degrees. The degree on the bottom is 2. That one's the obvious one. The degree on top, I don't have an x. Okay, so then my degree will be 0. So the degree on top is 0. The degree on the bottom is 2. So the bottom is bigger. And what happens in that case? So if the degree of the denominator is bigger, so that's this case, that's case 2. The degree on top is less than the degree on the bottom, then our asymptote, our horizontal asymptote is y equals 0. So let's go ahead and put that in, y equals 0. Okay, and let's go ahead and graph all of these. So here's my y-intercept, 0, 1. And then let's go ahead and graph all of our asymptotes. So y equals 0 for the horizontal. Here we go. And then x equals 1 and -3. So here is 1 and -3. There we go. Okay, so now what do? This is all we have. So now our graph is kind of split into 3 regions, right? There's this left region over here, and then there's this middle region, which I'll use a different color, right over here, and then there's the region on the right, which I'll use a different color. So we have 3 different regions, and we don't have many points. We have all the asymptotes, but we don't have many points. So then what do? Well, let's go ahead and do what we did on top. Let's go ahead and plug in some values for x. So let's start with this region on the left. So I'm going to pick an x value in that region, and I can pick, let's say, x equals -4 or -5. I'm going to use -4 because that's a bit easier to work with. So x equals -4. And then I have my equation up here. So y is equal to -3 over -4 squared plus 2 times -4, x squared plus 2x, and then -3. And this, by the way, you can, of course, do on your calculator and just plug that in, and that should be a lot quicker than doing it by hand. But let's say I get -3 over, that's 16 minus 8 is 8 minus 3 is 5. So it looks like I get -3 on top and I get 5 on the bottom. So that tells us that when x is -4, my y value is -3/5, or -0.6, I think. So let's go ahead and graph that point. So when x is -4, 1, 2, 3, 4, my y is going to be a negative number, so somewhere down here. And that's really all we need, even though it's just kind of one random point. What that tells us is that it tells us the graph is going to look like this in this part, in our first region, rather than up here, okay? Because our point that we saw is below the asymptote. And that's really all we need. And then let's go to the middle region right here. Now I do have this one point, that's the y-intercept, but let me just go ahead and pick a few more points just to kind of see what the graph really looks like. Let's say I'll pick, so that's when x is 0, let's say I'll pick x is -1. And again, this might look like a lot of work, but if you have a calculator, I think this will be a lot quicker. So y is equal to -3, and then x squared plus 2x minus 3. So x squared plus 2x minus 3. So again, -3 over, I get 1 minus 2. So that's -1 minus 3 is -4. So I get positive 3/4 or 0.75. So when x is -1, I get 0.75. So that's going to be, somewhere over here. And then let's say, if I'm still not sure, I can pick more point. Let's say I want to pick another one. Let's pick x equals -2. And then y is equal to -3. I have -2 squared, x squared plus 2x minus 3. And then what do I get here? I get -3 over, that's 4 minus 4 is 0. -3, that's going to be 1 again. So I get this point. X is -2, y is 1, so that's going to be right over here. So then I'm sure we can guess this is going to look like a parabola, actually, right? Because we know our graph will have to go approach the asymptote, like so, and like so. And then it's going to look like a parabola right in the middle there. Okay, and then let's go ahead and look at our very last region, which is over here. Let's pick an x value that's in that region. And let's say I can pick x equals positive 2. So I'll do it down here, x is 2. And then I get y is equal to negative 3 over x squared plus 2x minus 3. X squared plus 2x minus 3. I get negative 3 over, that's 4, plus 4 is 8, minus 3 is 5. When x is 2, y is, again, negative 3/5 or negative 0.6. So that's going to be, again, somewhere down here. And that's really all we need, because that tells us my graph is going to look something like this. Okay, so for this problem, we had to do a lot of work, because we were not given that many points, because there was not an x-intercept, and then we had all these asymptotes, so we weren't sure what the graph would look like. So for this one, we had to pick 3 or 4 points to check. But again, that's really the best idea, the best method to graphing these, which is why, again, like I mentioned before, many times rational functions are very, very difficult to graph. But again, the idea is the same. You find the key features. Sometimes you need to find some more points. And yeah, so in this case, we have our graph, which looks kind of cool because there's 3 parts. But again, graphing it was not super simple. Domain, x is all real numbers, except x cannot be negative 3 and 1, because we have 2 asymptotes in this case. How about my range? All real numbers, except y cannot be 0, because that's my horizontal asymptote. All right, let's do one last one together, and then I think there's going to be 4 more graphs for you guys to try on your own, but they're going to be pretty similar to the ones that we're going to do in this video. Okay, let's start as always with my intercepts. X-intercept, you set the top equal to 0, the numerator. How do we do over the quadratic? Well, we factor it, x plus 4, x minus 4. So I get x equals negative 4 and 4. So I actually have 2 x-intercepts, negative 4 comma 0 and 4 comma 0. That's going to be here and here. Y-intercept, as always, make sure you set x equal to 0. So I get y is equal to 0 squared minus 16 over 0 squared minus 0 minus 6. All those zeros will cancel out. I just get negative 16 over negative 6, which you can use a calculator to find what the actual number is. That's going to be about 2.7. And let me graph that as well. So that's going to be the y-intercept, 0, 2.7. Okay, how about my vertical asymptote? Set the bottom equal to 0, x squared minus x minus 6 equal to 0. Factor x minus 3, x plus 2. And then I think I get 3 and negative 2 for my vertical asymptote. So x equals 3, x equals negative 2. And then last but not least, horizontal asymptote. We compare the degrees. Degree on top is 2, degree on the bottom is also 2, and my leading coefficients are both 1. So I get y is equal to 1 over 1. If the degrees are the same, then we compare the leading coefficients, and 1 over 1 is still 1. And here it is. Let's go ahead and graph the asymptotes. X equals 3 is right over here. And then x equals negative 2, that's going to be right over here. Okay, so this one's kind of nice because, again, we have the 3 asymptotes, but here we have 3 points to work with. Okay, so right away, I see that on the left here, my graph will look like this because I already have a point that's on the bottom here. So I know my graph will look like that. And then let's look at the one on the right, the region on the right. My graph will be down here as well because I have a point in that region. That was my x-intercept. And then again, the one in the middle, we also know where that's going to be. That's going to be on top. But let's say you want to be more sure. You want to pick a few more points just to see what the graph looks like. So let's go ahead and see what happens if we do that. Let's say I want to pick x equals 1 just to be sure. So let's go ahead and plug that in. I get y is equal to x squared minus 16. So 1 squared minus 16. and then x squared minus x minus 6. X squared minus x minus 6. So that's going to be negative 15 over, let's see, negative 6, it looks like. And then go ahead and plug into your calculator. I get 2.5, 2.5. So when x is 1, I get 2.5. So x is 1, y is 2.5. So that's about, where the other point is. A bit slightly lower, I think, because the other one was, 2.67. So right about there. And then let's see, we can, pick more points as well. But I think you get the idea. Here, the graph will look, again, like a parabola. So something like this. Okay, again, you don't have to be perfect, but just a few points for our sake is good enough. And then lastly, domain range, all real numbers except x cannot be 3 and negative 2. And then range, all real numbers except y cannot equal 1. Okay, so that is it in terms of graphing rational functions. This is as complicated as we'll do. Next time we're going to see a new key feature, but I think that's going to be slightly easier than the ones we just graphed. But again, even though this is complicated, the idea is always the same. So make sure you have this chart. Take the notes on this chart. How do you find all these key features? And then again, sometimes you may need to pick additional points just to see what the graph looks like. Okay, so as always, please take notes and then finish the last couple of graphs there by kind of doing doing the same way we just did. And then let me know if you have any questions. We are winding down with the school year. I think there's going to be just one more video to cover, and then we'll be done with all the material actually. So as always, thanks for your hard work, and I will see you guys next time.